Tu. Yo, 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 welcome, bienvenidos. It's been a while. No. Es en vivo, pero la conferencia es del año pasado, que quiero ver un par de vídeos y me parecía guay compartirlo con ustedes. How is my beautiful YouTube people? We are gonna do a couple of things today. The first one is gonna be watching a couple of videos from React Conf from last year. And then we will go into classifying a couple of music for string radiox. Let me see. San Canela, bro. ¿Probaste string radiox? ¿Te llegaste a registrar? Did you sign up for string radiox? Ba-ba-bum. There we go. Let me see if the music is working great. All right, let's see. Let's see, because I want to add the YouTube video. Oops. 1 second. There is the first video that I saw that is super interesting is this one about how to build the new Facebook with React and Relay. I have not really used Relay before, so I'm very excited to see what's that going. What is that about? Let me see if I can add the chat. Well, all right. I don't really like browser. Yeah, probably that's gonna be better. Anyway, we are gonna start with this one, which is the how they build Facebook. So let me turn down a little bit the music so you guys can hear that. Browser, share, window capture. All right. Transform, edit transform. Okay. There we go. Dope. Okay, I'm gonna turn down a little bit the music. Okay.
Hey, everyone. As Devin mentioned, my name is Frank, and I'm the engineering manager of the Web UI platform team, and we're part of the React group at Facebook.
Have you ever
This is actually my
used
first time attending ReactConf.
Relay?
Thanks. This is actually my first time attending ReactConf, so I'm nervous to be standing up here, but thanks. But so excited to tell you more about how we're building the new version of our website and a few things we learned along the way.
Let me see. Guys from the chat.
So this is...
Guys from the chat, can you hear the sound from the conference correctly? Is the sound working fine? Because I don't know.
This is what the new website looks like. But first, let's take a look at how we got here. Facebook began as a... simple website made with PHP. I know, it looks really old, right? All right, here we go. Facebook began as a simple website made with PHP, and over the years, we built richer and more interactive features like messaging and live videos. But our pages started to look less like...
Do people actually use Facebook nowadays?
All right, less like this little island of PHP, and more like an iceberg of JavaScript and CSS. Engineers wanted to build with React and Relay, but each time they tried, it only added to the iceberg, making the website heavier and slower. It was extremely difficult to build the product experiences that we wanted with the technology stack that we had.
What is Relay?
There were too many different ways of doing things, and moving fast for so many years had accumulated debt that was now slowing us down. We wanted to deliver a better user experience, which to us meant implementing a design system with a modern design language and support for theming. As Yuzi mentioned, we care deeply about accessibility, and we wanted to build a component library that embedded best-in-class support for this out of the box. We wanted to speed up the site, but performance is not just about page loads. A truly app-like experience on the web also delivers seamless interactions whenever you click, tap, swipe, or scroll. And all of these things were technically possible with the old stack, but they required so much work to deploy and maintain across all the different ways of building UI that we never got around to it. We knew that a redesign alone wouldn't be enough. We had to rethink how our website was put together and rebuild it from the ground up. So we constructed our new website as a single-page app. React organized our HTML and CSS into HTML and JavaScript into components from the top down, and with GraphQL and Relay, we co-located our queries declaratively in our components.
I'm curious, how many of you that are watching right now the live stream do you use in production GraphQL nowadays? I'm very curious. I'm using GraphQL for developers in dev.com, but apart from that, I have not used GraphQL for other kind of project or even in my current company. And I'm very curious because actually, they're like, I'm not hearing much about GraphQL lately. And that doesn't mean anything. That just simply means that people are just focusing on other stuff, or the hype is going more into other kind of projects. But I'm very curious. What I've just seen is that apparently Relay, it's something built on top of GraphQL for production-ready apps. So let me see if I can share. If you can see this. Where is this? So it says the production-ready GraphQL client for React, built for scale. Relay was designed to be performed from the ground up and support scaling your application to thousands of components while keeping management of data fetching sane and fast iteration speeds as your application grows and changes. Okay. so that they can be fetched in a single GraphQL request. Okay. We'll handle all the heavy lifting to ensure the data declared by your component is fetched in the most efficient way. For example, by deduplicating identical fields, fetching as early as possible, among other optimizations. I see. That's very interesting. So it's basically something built on top of GraphQL to be more efficient in terms of like the requests and the queries that they perform. Data-driven React applications powered by GraphQL. Okay. And that's also Relay handles the state management for you. Principles, prerequisite guides, debugging, server-side persistent queries, type testing, Relay, local state management. Okay, yeah. It looks like we can create a new type called node, querying local state. Query render, GraphQL render query. Interesting. That's very interesting, actually. To be honest, like at the end of the day, I'm very curious to see like how many real production applications will require something like this. Like how many of them are actually, like how many applications are out there has the same needs as Facebook does? Because this is obviously super beneficial for Facebook. I'm sure that this will be very beneficial for other products like Twitter, but I'm really curious to see like how many real production apps require something super sophisticated as Relay. I'm just curious. Actually, Twitter Relay, React Relay, are they using that technology on Twitter? Oh, that's very interesting. It says GraphQL Relay at the end of Redux. Perhaps building an agile, maintainable architecture with GraphQL. Dan Abramov. Ah, I see. It was written 4 years ago, so that's a long time ago. And I think like Redux is still around. Optimistic and offline first UI. Huh. I do think both Redux and Relay need to change to work better together. I see. Okay. Makes sense. Let me reduce that. For those of you that are watching here the streaming, so we are going to start first on YouTube, and then we will switch after 1 hour and a half.
Only thing that
Twitch.
we hadn't reorganized into components was CSS. But we didn't want to do it just because we could. CSS is already declarative and built into the browser. And for many of us, the ease of tweaking styles is one of the most fun parts of building for web. Many websites, including my own, use idiomatic CSS, and it works great. So the idea was not to discard it or reinvent the wheel. It was to explore whether we could make it easier to maintain when we have hundreds of engineers working together on the same code base while retaining all the good parts of CSS that we love. Since Christopher Shadow presented this idea in 2014, many great open source libraries have been developed to embed styles and components. And they're each awesome in different ways. We had some very specific constraints for a new website, so we decided to create our own library that synthesizes ideas from many different frameworks, including introducing a few of our own. While the library is not yet ready to be open source due to dependencies on our internal static resource infrastructure, and even the name is still experimental, I'd still like to share some concepts from it with you today. But don't worry, we're not asking you to adopt anything. Our library has been working well for us, but if you don't share requirements or use cases, something different might work better for you. Our #1 priority was to make it easier for styles to be read.
Okay, I guess like here, what's the name of this guy? Frank John is trying to basically say we are experimenting these. Don't expect like this will fit all your application needs, which is great. It's a great advice because I can see that Facebook needs are not the same as your application needs or my application's needs. So I appreciate that. At the same time, I guess like this talk is more like sharing how they build the new Facebook rather than selling people why they should adopt these new technologies. But at the same time, like if I see React and Relay, I could be like, oh, maybe Facebook adopted that. Maybe it's something that I should give it a try. So not super sure like how possible is to basically adopt this application right away, because he said like it will depend of our use case. So I will be very interested in if actually he can provide more insight over like the main requirements from Facebook and stuff like that. I can picture them, but you know.
Understood and safely changed when it's unfamiliar code. Or let's be real, even if it's your own. So let's take a look at some code. Here we have some simple CSS.
Mm-hmm.
And let's add some HTML. What color will this text be? It'd be reasonable to expect blue. After all, blue comes later in the list of classes where we use them. But CSS rule precedence actually depends on the order of classes in the style sheet.
Mm-hmm.
So you'll be seeing red, or at least the text will be red. Anyways, this is already confusing with just one style sheet and one usage.
Agreed.
If these classes were split across 2 files, the color applied would depend entirely on how they were bundled and the order in which they were inserted into the page. We tried to make this more straightforward. Using our library, we now author styles using a familiar syntax that is inspired by React Native and other frameworks. And we guarantee that the styles applied follow the order of arguments at each call site. You never have to scroll up or switch files to check your style sheet. In fact, if we switch the order of arguments here, the text would become red. We can now sort our style rules alphabetically or however you like. I'll come back to this later to explain how we made this work, but you can already see that we're still using CSS style sheets and class names under the hood, and this one change helped many engineers have confidence in their code when collaborating to build new features quickly. Another capability we needed to support was theme.
I'm curious. I'm actually doubting right now. I'm curious if actually Emotion or other CSS in JS React with styles. I'm actually wondering if other CSS in JS solutions out there follows the same rules. CSS, like let's say Emotion, CSS rules. There was a question over GitHub. Not sure if this is the right question that we're looking for, but it says I have 2 variables in my code. Which style is supposed to override the previous one, which is a specify. Okay. However, as I run the code through Webpack and structure CSS, it's not working as supposed. By looking at the attribute, it seems that there's no order in those styles. Just the later one overrides the former one, which is not how hashmap merging works, just how class name works well. I see. So probably that's also a problem that you will have over Emotion. Okay, let's keep watching. It's okay. I was just curious about that because it's a nice problem that they are solving with that solution, I think. Themability.
Theming. And one of the first things our designers asked for was dark mode. We used to write a lot of code that looked like this. We'd put a class on the body or some ancestor and override styles. Or like this, we'd try a redesign, and once it shipped, new engineers had no idea which blocks were safe to remove, so inevitably, this would happen. It's all fun and games until the specificity wars. By adopting CSS variables, we eliminated some of these anti-patterns and made the cost of a theme proportional to the size of the color palette instead of the size or complexity of the component library. You may have noticed that CSS variables propagate their values to their subtrees in the same way that React Context does. This means that
yeah, I like that approach. I think when I've gone through the dark mode sort of approach, I was actually using kind of like not really CSS variables, which I think like I should have used those. I was mainly using like, well, I mean, kind of like similar, but an object with all the styles, colors, and stuff like that, and then like I was using that object and overriding those values. But I really like this approach, and I guess like later on they will just simply add light theme or dark theme to the body class name or to the parent wrapper class name. Okay, I like this approach.
you may have noticed that CSS variables propagate their values to their subtrees in the same way that React Context does. This means that for themes that only remap CSS property values like colors or spacing, we don't need the full power of React Context, and we can delegate all this restyling work to the browser.
I see. Nice. Themes, and then you pass a theme. That's very interesting actually, because I was using all the time the theme context, but that makes things cleaner in my opinion.
Like colors or spacing, we don't need the full power of React Context, and we can delegate all this restyling work to the browser. CSS variables can also be used to theme certain types of icons, especially ones that are monochrome. Instead of passing SVG files to image tags, we inline SVGs into the HTML using React. We did this by taking each icon's React.
Okay. But I think, what do they mean by any way? Like, I've been using this for a long time.
We did this by taking each icon's SVG file and generating a React component from it, which enabled us to style the icon according to its props and the current theme.
Oh.
Under the hood, this works using CSS variables just like HTML. Because these SVGs now are effectively JavaScript, they can be bundled and delivered together with their surrounding components for a clean one-pass render. No more flickering of icons that pop in afterwards. And these icons can change colors smoothly at runtime without requiring an additional download.
Okay, I like that.
In case you missed that, here it is again. Focus on the menu icons.
Whoa.
All right, shout out to our designers for making this so pretty. Build steps mean that what we write does not need to match what we send to the browser, and we can take advantage of this for accessibility. Here's one example. Many browsers today have a font size setting that defaults to 16 pixels, and when you change it as a user, it effectively alters the browser's built-in style sheet to apply a different font size to the root element. To respect this setting, we needed to avoid overriding this rule, and we needed to change all our font rules to use rems, which are a unit relative to the root element's font size. However, designs are usually made in CSS pixels, and the conversion rate is a tricky 16 pixels to 1 rem, so we were never going to get the math consistently right by hand. But we can make the library do this conversion for us. We code in pixels, and the browser receives values in rems. Now when you change your font size setting in the browser, the text updates automatically. All right, this one's really subtle, so look closely at a specific line of text. You can pick any one, but keep staring at it. Ooh. This gives people the option to change only the font size or only their text size without accidentally triggering a tablet or mobile layout like full-page zoom might.
Do you... Hold on.
Because the styles we write are now embedded in...
Did you notice the difference? Let me do it again. Oh yeah, That's interesting. And how did they do this? What we write in our components, font size 15. What we send to the browser. I see.
And rems. Now when you change your font size setting in the browser, the text updates automatically. All right, this one's really subtle, so look closely at a specific line of text. You can pick anyone, but keep staring at it. Ooh. This gives people the option to change only the font size or only their text size without accidentally triggering a tablet or mobile layout like full-page zoom might. Because the styles we write are now embedded inside JavaScript files, we can also use JavaScript tooling like type checkers and linters. This helps us catch and fix typos, detect unused styles and eliminate dead code, or even suggest switching to a component to avoid cross-browser pitfalls, or detect unused styles and eliminate dead code, or even suggest switching to a component to avoid cross-browser pitfalls. But not every...
But in my opinion, that's not like the biggest. I mean, that's okay. But if I'm correct, the extensions that I have for CSS in JS in Visual Studio Code already prevents me for bad words or things that are not correct. The only part that I think is super interesting is the part that they removed unused CSS, in my opinion. That's super cool.
Everything is statically analyzable, so sometimes we need to rely on runtime checks. In our development environment, if elements are inaccessible, incompatible with dark mode, or are extremely slow to render or fetch data, we can visually and functionally block them out. By providing a highly visible contextual error with actionable recommendations, we can help engineers quickly solve the problem.
Nice.
So far, I've only shown styles local to a file, but sometimes we need to be able to pass styles around. For this, we have composition. Here's a quick example, but I won't have time to go into too much detail in this talk. We have a base component here that accepts a style object that it can merge into its own styles. And we have another component that passes some of these styles into the base component. The style object can be strongly typed and only accept specific properties such as margin or even specific values such as 0 or 4. This adds flexibility to how components can interface with other components in a structured way. All right, let's jump back to that first example and dive a little deeper. I've made red the default and added a font size rule to help illustrate how our library works. From the style rules at the top, our library generates atomic CSS. This means that each class refers to a unique property value pair. The library then transforms the values in the component to refer to these generated classes. If a component uses style composition and has external styles to merge, this is where our library stops because we need to retain the CSS property names to handle dynamic collisions. But since this component only has local styles, it can optimize further using static analysis. It turns the class name value into simple Boolean and ternary operators for each generated class in order to handle property name collisions. And this eliminates the function call. Now there's no more need for the styles block at the top, so that's eliminated as well. All we have left is the optimized component and the generated atomic CSS in a separate file. We've eliminated almost all the runtime costs of CSS and JS and retained compatibility with server-side rendering. When we take all the generated atomic CSS from across our site and combine it into one style sheet, we can achieve more savings. To illustrate this, with the old way we wrote styles, we would accumulate lots of duplicate rules, like these ones, within and across files. Our new library merges these rules under one class name.
Okay, that's
And
cool.
browser engines are optimized to match elements that have this type of simple class selector. Thanks to this deduplication, the size of the generated style sheet grows much slower than the number of styles or features that you write, because it's proportional to the number of unique declarations. On the old site, I measured a total CSS size of over 400 kilobytes. And that's just for the homepage load after gzip compression before you start interacting with the page or visiting other pages. With all these changes to how we author styles and generate CSS, the new site requires only 74 kilobytes of CSS total shared across all the newly built pages and interactions, and that includes the dark mode implementation.
Wow. Wow. That blows my mind. That's incredible, honestly.
And now I'd like to welcome Ashley to talk about how we restructured our data and JavaScript.
I see. So there is like, there was 2 videos. So the first one is about all the styles. The second one is about it's about relay. We can watch the relay. ¿Qué os ha parecido? That was very interesting. I'm
And
actually
the
very
generated atomic component.
very curious
Sure.
about this part. So he said you could reduce. And to be honest, like what they are doing here is just selling why we should be using style X. But honestly, it's great. It's great. There are a couple of features from style X that is great. Actually, I don't have much context over how many of those features actually, like, you know, Emotion or other CSS and JS solutions out there has. But it's definitely something very, very interesting. And, you know, in terms of optimization of your bundle size, in terms of avoiding like all the cascading effects, like all the, you know, like basically one of the main problems that he mentioned that I think is very interesting is in the way the CSS is being generated and it's being parsed. So he mentioned that, you know, if you have like different class names, like the order that you put your class names in React is actually not warranty will not basically make sure that you will have those styles applied in the same order, because it will basically depend on how Webpack is building your CSS and how that CSS will be added into the output or the final CSS bundle. So I think it's very interesting that with this utility that or this library that they created, actually he mentioned that they respect the order that you place the CSS, right? So I don't know if I can find the example. Let me see. CSS variables. No, where was this? I think it was around here. Let me see. Composability. But actually he added an example over implementation details. No, I think it was here probably. No, I think it was before in the video. Icons. Oh, there we go. Here it was where he was explaining about that, and I think it was very interesting because he said, yeah, like if you have this example right there, like blue and red, even though you add like red and blue in your class name inside the React component, that will not guarantee you that blue will be applied after red, because it will basically depend on how this CSS is generated with Webpack. And the cool stuff about that library that he's mentioned or he's talking about is that it will actually preserve the order that you apply that here. I'm actually wondering, like, I will need to double check this later on in case to see how Emotion or other CSS and JS libraries work with that. But that was very interesting. Also, he mentioned some more interesting stuff like you know, about this was okay. I think it was a great pattern anyways. primary color styles dot create primary color. Yeah, about this rem versus pixels, I think it was very nice because he mentioned that you could write everything in pixels, but at the end of the day, it will be generated using rem, so it will warranty you the consistency over your base pixels font size. So that's very nice. Type checks, okay. I mean, I know like there's some utilities and some libraries in VS Code that actually warranties you these. Like we'll check the CSS and we'll make sure that everything is properly written. But something that was very nice that he mentioned is that you can actually optimize the final bundle. I don't know where was that. Yeah, like basically they can optimize the bundle by checking what are the properties that are no longer being used and stuff like that. So that's very nice, very nice, very nice. Very exciting technology. So, and then we have this other video, which is the second part, which is about Relay, which I'm very excited because I've never used Relay before. So I'm very curious to see how did they implement this. By the way, very great marketing strategy that they use here, basically splitting up the video into two parts. I would actually expect them to be more clear on the titles, like this is for CSS, building a new Facebook with React and CSS, and then here Relay, but it's okay, let's keep going.
So as Frank said, the new website is a single-page web app powered by React, GraphQL, and Relay. If you're not familiar with these, GraphQL and Relay help us fetch and manage our data. And when I say data, I mean anything we'd need to get from an API endpoint from the server, like what the current user's name is. GraphQL is a query language, allowing us to specify which pieces of data we need. Relay is a framework that...
Okay, something, I mean, I really appreciate, like, I'm sure this video will be amazing, but something that I don't really like when a presenter is actually reading the notes. I know, like, honestly, by being on Facebook and giving this presentation, you will have a lot of people watching you, so I completely understand that you don't want to mess around, but I don't know, like I've just think like it's nice when you are more like freestyle sort of way.
That integrates with React for constructing GraphQL queries, and it handles all of the data fetching for us. So performance is an issue for a lot of websites. People are looking for fast with an app-like feel. This means a fast startup with a responsive, engaging interface. By standardizing our tech stack, we were able to rethink how we would be able to introduce the functionality people wanted in a performant, sustainable way, even as we operate at engineering and product scale. We've been able to make some changes to how we handle static resources, and the Relay team has some exciting new features that have made both our code and data faster. So one of the big challenges of a client-side rendered application is how to decrease time to visually complete. This is the amount of time it takes from when a user starts navigating to a website until all of the visible or above the fold content is rendered. The way we would traditionally fetch data in a client-rendered app might look something like this. First, we need our JavaScript, and then the JavaScript kicks off requests for our data, and we render a loading state while we wait. Eventually, when we have the data, we can render the final content for our users. But that means our code is a bottleneck for the data, and we want it to do better. And because Relay handles...
It says request, render, initiate request, complete render. Yeah, so you download the code, you do the initial render. In this case, you will show like a spinner. You will do the fetch data in the background, and once that finishes, you will do the render. So I guess like their main goal could be to basically collapse the download code and the fetch data into the same step, because if you actually can collapse both of them in the same step, I can see like you can reduce more time, right? Like if you know what data you need to fetch beforehand, you will just be smarter on the way like this pipe works. Let's see.
All of our data fetching for us, it statically knows what data a page needs. It has a global knowledge of the data requirements for the entire system. We can leverage this so that as soon as our server receives a request for a page, it can immediately start generating the data and downloading it in parallel with the code.
Wow.
By doing this, we can render the final content early.
Wow. Whenever you see this kind of like graphics and you see these kind of like optimizations, they sound like, oh my God, I want to do this.
Earlier. There's a little trick hidden in this timeline, though. The client's kicking off the request for the code, but the server kicked off the request for the data. Once the server has the data, how do we get it to the client? We do this by taking advantage of something called HTML flushing. When a browser requests an HTML document, it receives the response in pieces in the form of network packets. As it receives them, it incrementally parses the HTML, and this happens even before the entire document has been downloaded.
What? What? Yo, is the first time that I'm learning about HTML flash. What? Wow. What? So it's basically like making the HTML. It reminds me like multi-part, where basically you have a big file that you split it up into chunks of smaller packages. The flash method. Oh, by the way, okay. Anyway, let's keep going. The flash method is used when you need to send the contents of the stream buffer to the associated underlying object. For example, a node or file represented by the URL that is the source of the stream object. This will ensure that all changes made to the context have been written. That doesn't help. Flash resources early. Speed it up. Wow. I've never, guys, I really love page speed service was turned off on August, blah, 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 blah. Wow. Guys, that's incredible. And it's not new, because it's been like, this blog post has been there for a while, like 3 years already. But actually, I've never heard about HTML flashing. There are a lot of changes to overcome when optimizing the page load to speed of your website or web app. One of these is getting your most important assets downloaded to the client as quickly as possible. These assets likely include one or more CSS files. Uh-huh. Wow. That's incredible. That's very, guys on the chat, have you ever heard about HTML flashing? Because it's my first time. I feel in this live stream I'm learning so much. It's the first time that I've heard about HTML flash. Early flash is possible to do because HTTP support a feature called chunked transfer encoding. I see. Yeah, this reminds me to the same multi-part encoding when sharing videos. Wow, that's amazing. Guys on the chat, have you ever heard about HTML flash? Have you ever heard about HTML flash? It's amazing, actually. Let's keep watching. The client can then start parsing these parts before it has received entirely of the response. In the case of browsers receiving HTML for a web page, you can send down the head section of HTML. Wow. Early flash response. Caveat. That's nice. I want to see it. One important caveat to keep in mind regarding early Flash is that once you've sent part of the response, you cannot change your mind and do something else, like redirecting the user to another page. This represented some difficulty for me in adding early Flash to this blog, as I have some logic to redirect the user under certain circumstances. Okay. Okay. Yeah, but it's incredible. Like the benefits or the improvements that you can get is incredible. Early Flash is a nice optimization you can employ to speed up web pages load on sites that have to do any non-trivial server-side rendering. As far as implemented, the work I've done so far is just first step as trying out the technique. There is more work to do optimizations like further. Nice. Let's keep watching, but very, very interesting thing to learn.
Awesome.
Oh, no, that one.
We can take advantage of this behavior by incrementally generating and sending the markup. We start with the markup that is fastest to generate, such as meta tags and CSS and JavaScript resources that we know all pages and users are going to need. We can flush this incomplete markup to the client almost immediately after receiving the request. And when the browser receives it, it'll start to fetch the additional resources that it discovers. This is a huge win even by itself, because it lets the client start to download the CSS and JavaScript much earlier in the page load, in parallel with the server still generating the HTML. Meanwhile, the server moves on to things like page and user-specific resources. These are slower to compute because they're more unique, and we need to know things like what A/B test the user is in. At this point, we can also start to compute the relay data on the server. We continue with this process until we've reached the end of the document. Here, we wait to send this to the client while we continue to work on generating the relay data. When it's ready, we add the relay data and flush the rest of the document. This lets us download the JavaScript and data in parallel. We're already downloading these JavaScript resources while the server generates the data, and then we stream it down at the end. And note that while I only covered the initial page load case, we can also use parallel fetching on the client for things like page transitions, modals, and tooltips. In those cases, we provide information about what the queries will need in the same place that we fetch the code that we'll need.
I definitely love this idea, and I definitely see the the value that you can get out of that. I could say that my main concern is how much complexity are you adding to your backend logic, which is a fair, probably if you're Facebook or you are other big size products out there, you could definitely do this. You have the resources, you have the money, you have even the requirements to do things super fast. But I'm actually wondering, a medium-sized product or a medium-sized application, how much important this is. I mean, for sure, it all depends where your customers are and how much fast you need to deliver your product. But I don't know, I could be curious to know more about the complexity to add this HTML flash, and because the values and the benefits of this, I can totally see that. Honestly, it blows my mind. I've never learned anything like this before, and it's incredible. Basically, you're able to send back to the client different chunks of the HTML, so the client can download that beforehand, and the server will keep doing whatever stuff they need. So, I mean, it's totally awesome. But I could be curious to know more about how, implementation details, how easy is to add these, how much complexity will add this to our code base, how much, it's basically all of that. Because I from the blog post that we saw, there are some caveats, but overall it's a very smart idea, and wow, that's great. I don't know, guys, if you have used HTML Flash, but if you so, just put me a comment or let me know your thoughts in the chat as well.
While final render is important, we also care about time to first paint. Time to first paint is how long it takes us to put the first round of pixels on the screen. When someone's waiting for a page to load, our goal is to give them immediate feedback. And ideally, our first paint should be a well-designed loading state. By putting up UI skeletons of what the page is going to look like, the user knows the page is loading, and they can begin to orient themselves to where the content will be. Then, when we have everything we need, we can render the final content. And similarly, there's code that we need after this, like analytics and setting up real-time subscriptions for things like live comments.
Yep.
And these don't affect the pixels on the screen. But let's look at our timeline again. Here we have the code downloading in a single block, and we can't render until after it's all downloaded. But that's blocking the loading views on code that isn't required right away. So why are we downloading it before we show the loading screen? So we want to use code splitting to divide this into pieces. But depending on how we do it, this can hurt performance because we have to execute code, and that pushes out when we can download it. So this means dynamic imports aren't quite right for our case. With this model, we're waiting to fetch the actual implementations, and so we're actually executing the first batch of code. And this is too late. In order to fix this, we need to know statically what code we're going to need and when we'll need it, so we can download the resources as early as possible without waiting for any code execution to happen. To statically know this, we need to be able to differentiate between what we want to delay to the second phase from what we want to delay to the third phase. And we also need to be able to differentiate between these things that we want later, perhaps as a true at-runtime dynamic import in response to an interaction. With a dynamic import, we don't know when the resources will be needed, so we don't know what to bundle together and what should be in its own bundle.
Stop, because I feel I need to see again, because I don't fully understand what was the problem that they faced. So this is very clear, right? So you have 3 phases. So in every phase, you will need certain data and say certain information. Like, okay, here you don't need anything. You will just trigger some data requests. In the second place or in the second phase, you will need like the images, data such as text, who is the author of the posts, etc. And then on the third phase, you will have like the analytics parts, etc. Like things that are not really critical in the first sprint. So I totally get that. I totally get like you will have different phases for loading a certain data and rendering certain components. But actually, I want to see what's the main concern, like time to interact. How did they solve these basically?
Render until after it's all downloaded. But that's blocking the loading views on code that isn't required right away. So why are we downloading it before we show the loading screen? So we want to use code splitting to divide.
Yeah. So she was explaining that problem, like, you know, if you are on the third phase, you actually don't need all of these data about like how many likes, how many people voted for this, what are the comments, until the user will interact with that piece, right? So you will not, like, that's not in the critical path of that component. So that's basically what she's explaining there. Then
divide this into pieces.
So she said, well, we could actually split it up into pieces, into different chunks that we can download at certain times of the application. So the problem right here is actually understanding, like, okay, so we know like we will have different data for different specific times of the life cycle of the component. So she split it up into 3 parts, which is the initial loading. Here is we are loading the data, or we are downloading the data, and here is like the analytics stuff, so the extra part. But you know, let's
depending on how we do it, this can hurt performance.
That I understand. Like, depends on how do you download this part, it will hurt performance, because if you're not smart enough in the way you download this piece of code, you will delay the time to first render and stuff like that. Let's see.
Because we have to execute code, and that pushes out when we can download it. So this means dynamic imports aren't quite right for our case.
Dynamic imports are not quite right for our case. I see. Okay.
With this model, we're waiting to fetch the actual implementations, and so we're actually executing the first batch of code. And this is too late. In order to fix this, we need to know statically what code we're going to need and when we'll need it, so we can download the resources as early as possible without waiting for any code execution to happen. To statically know this, we need to be able to differentiate between what we want to delay to the second phase from what we want to delay to the third phase. And we also need to be able to differentiate between these things that we want later, perhaps as a true at-runtime dynamic import in response to an interaction. With a dynamic import, we don't know when the resources will be needed, so we don't know what to bundle together and what should be in its own bundle. We don't know when to download.
I see. Okay, so yeah, I understand the problem now, because basically she said, by the way, let me let me close a little bit the window. 1 second. 1 second. All right, there we go. So I understand the problem that she's saying, which is, even though you do the dynamic imports, which is basically delaying, like only downloading or rendering that component until you know, like that page or that view is shown to the user. She said that basically you don't have control over which data should be prioritized. So you can have like a component that basically have like 3 parts which are dynamic. Let's say the analytics, the data for the picture, and something else. And she said that even though you can download all of them dynamically, right? So you could say, I want to download each of these dynamically. Since you cannot specify in which order and which should go first, that may impact the performance, because actually you don't have control over the download process. Because if we go back to the first, like to the previous example, she was saying that we want this part to go first, second, and third. So basically, even though if you download, like dynamically download like each of these parts, you don't have control over what should go first, basically. And I think that's the problem that she's saying. And now like, she will provide like a solution, I guess with Relay.
Differentiate between these things that we want later, perhaps as a true at runtime dynamic import in response to an interaction. With a dynamic import, we don't know when the resources will be needed. So we don't know what to bundle together and what should be in its own bundle. And we don't know when to download them. So we created 2 new declarative APIs. And let's look at a codependency tree to see how they work. The first new API is import for display. When we add an import for display edge, it moves everything below it into phase 2. And the second API is import for after display, which pushes everything below it into the 3rd phase. With this, we're able to take our code graph and split it into our 3 phases at build time without having to run any code on the client. And even though these edges are completely separate in the dependency tree, we know to bundle them together in this way. We also know the order that we need to download them and when.
Wow.
This means we can take our single blocking download and
look at that. That was so nice. Look at that.
Import for display edge.
Dependency trees. I love them, by the way. I love trees. I mean, like the data structure. For sure, I also love trees.
It moves everything below it into phase 2. And the second API is import for after display, which. And let's look at a codependency.
Let's see.
When we add an import for display edge, it moves everything below it into phase 2. And the second API is import for after display, which pushes everything below it into the 3rd phase. With this, we're able to take our code graph and split it into our 3 phases at build time without having to run any code on the client.
This is
and even
crazy.
though these edges are completely separate in the dependency tree, we know to bundle them together in this way.
Wow.
We also know the order that we need to download them and when.
This is crazy. This is crazy. I really like them. At the same time, I believe that this is probably not a problem that we will face on a regular basis on our jobs. Like, this is a very optimization problem. And, you know, like when you're on a early stage startup or when you're in a medium-sized company, probably you don't need to worry too much about these performance optimizations, unless if, for example, you are building a product for like people who doesn't have access to really great internet, or if you want to reach like a more global market. But you know what, like most of the times, like I would say that this is a very nice optimization. But nowadays, like the mobile phones, the desktop, etc., the internet connections are getting better. So I would say that great for optimizations, these micro optimizations, but at the same time, I would say like this is probably something that we'll not really need on our daily basis. Like in a startups or in a product like Stream Radiox, we have way more problems to solve first, such as the product market fit, rather than focusing so much on how the UI is optimized. So, but anyway, I think it's a great example, and it blows my mind, honestly. Like this graph right there, let's see this graph and the way it handles all the dependencies in terms of data fetching. Incredible, honestly. It blows my mind. I don't know, guys, what you think, but it's blow my mind. But yeah, I would say that this is not probably for our use case on a daily basis, but it's really great to know like there are tools out there to solve that particular problems. But again, I would say that these kind of problems are very specific to products like Twitter, like Twitch, stuff like that. Facebook, Twitter. Let's keep going. Oops.
And even though these edges are completely separate in the dependency tree, we know to bundle them together in this way.
You bundle them together in this way. I'm wondering, so I guess they are using Yarn for this?
We also know the order that we need to download them and when. This means we can take our single blocking download and deliver it in 3 phases, which lets us execute it in 3 phases.
Wow.
The loading screen, the full page display, and analytics separately.
Wow.
And this did a lot for us. Because the analytics block doesn't affect the pixels on the screen, it isn't really a render. And so the final paint finishes much earlier. But most significantly, look at how early we're able to render the loading screen.
Yeah.
And this was all possible because of how we did the code bundling. Each phase will render exactly what we expect according to how the site was designed.
That's great.
But not only do we want to provide immediate feedback about loading.
This is great. This is a huge performance improvement. Incredible.
We also want to get the most critical content as early as possible. Time to first meaningful paint measures how long it takes for the primary content to be visible. And in order to do this, we really need the data to be present. When the query takes a long time, we're back in a case where we have to wait for the data before we can render the content. If we take a look at our queries, maybe the reason it takes so long for the server to return data is because we're fetching too much data, or data that's expensive to compute. And the question is, do we need all of this data just to show the initial content on the page? Maybe some of the data is initially hidden or rendered outside the viewport.
When you ask that type of question on a conference, I would expect it to put like, no! That's kind of like the typical rhetorical question, you know?
We usually won't need more than 1 newsfeed post to render the initial homepage content, so we shouldn't need to wait to fetch all of the posts before we can render anything on the screen.
Yeah.
So we want to treat the data that we need for initial render as the most critical data. This doesn't mean that we won't need the rest of the data, only that we can afford to wait just a little longer for it, if that means that our critical data can be delivered sooner.
Can you, by the way, thanks for the people who is liking the live stream. Can you actually imagine that you're Facebook? Like optimizing these kind of things is incredible and will save you a lot of money just because if you're basically reducing the workload of your servers, if you're downloading less requests like images, data, etc., like this is like honestly I totally see like the huge improvements and the main value that these kind of things will have over Facebook. Because the fact that, for example, you're on the homepage and you don't need to download 10 posts and you will just download like the critical path, the first post, for example, that will save you a lot of money. So honestly, this is incredible.
Afford to wait just a little longer for it, if that means that our critical data can be delivered sooner.
Yeah.
One of the new features in Relay is the ability to mark which parts of our query can be streamed down. So as soon as the first feed story is ready, we can stream it to the client without waiting for the rest. And we might also want to do similar things with non-list items. We can mark which information is less urgent, which lets us do things like get the name and picture displayed on a profile without waiting to generate the user's timeline. So given this query, we can mark which information is critical and which parts are less critical.
Wow.
By doing so, the server can deliver the critical data as soon as possible in a separate payload.
Guys, I'm vibing here. I'm vibing. This is amazing. This is amazing. Human work here.
This means that we'll be able to show the initial content sooner. And as the less critical data streams to the client, we can render it as it arrives. There's a performance quirk to this as well. This can also save us a tiny bit of time to the final render. With React Concurrent, these smaller pieces that come in later take less time to render than if we'd done them all at once. But this isn't the biggest win. Depending on viewport height, it's possible that the subsequent renders are things that happen below the fold, which means we might actually be visually complete much earlier.
No way. They also take into account the viewport height. This is amazing.
All of the optimizations we've talked about so far have a big improvement on loading, but we're still not quite done. We need to make sure that we're only sending down the resources that we actually need. And as it turns out, sometimes the way we structure our apps can make it so we download both code and data that we never end up using. This can commonly happen when we need to render two different variations of the same UI, depending on data or other conditions. For example, here we have two variations of a composer. If the user is part of our A/B test, they will receive additional functionality. We want to make sure that only users that are part of this test receive the extra code. And before, if we wanted to do this on the old site, the code was imported in the middle of the startup sequence.
Yeah.
But this is using the dynamic imports, and as we already talked about, the performance on this is pretty bad when we hit this during render. So we've moved the import to a new declarative API that's discovered via a build step. We can statically analyze that we only need this if they're in the A/B test, which lets us know at build time how to bundle these separately, and then at runtime know which version of the code to send down.
Whoa.
At the beginning of the request, we can determine if the user needs additional code for the A/B test, which lets us ship the right code right away. This only handles the cases that we can determine at the beginning of the request, though. What are things that are based on data? For example, a single post could maybe be a photo, or it could be a video. And when we render a post, we can't tell ahead of time what type of post it's going to be. This may depend on what type of page you're visiting or which user you are. This means that our component needs to know how to render both variations of a post. So it'll need to include the code and data requirements for a photo and the code and data to render a video. But what if a user visits a page and never ends up seeing a video? Then we unnecessarily downloaded and wasted a bunch of resources that we never ended up using.
Yeah.
And you might not think it's a big deal. It's just a little bit of wasted resources. But at scale, this is actually a huge deal, because a post isn't just a photo or a video. It can be a myriad of different things, like an event,
This is a huge deal at scale.
a song, an album, a fundraiser, and more. So if we downloaded all the data and code for all the different things a single post could be, we would end up wasting a ton of resources. So how do we handle this? GraphQL already handles this on the data side for us. We can model the different variations of our UI and describe the different types of posts it can be. When we write our query, we can also describe the data that we want back when a post matches a specific type. If it's a photo, we want the photo data back. And if it's a video, we want the video data back. And if it's a song, we want the song data back. When the server executes and returns the data for this query, if the post we're querying data for ends up being a video, for example, then we'll only download the video data in that request. That way, we can download the data earlier as part of the initial GraphQL request, without any additional data requests. However, at this point, we still need to wait until we start rendering to go fetch the extra code. So how do we address this? That's where Relay comes in. Relay has a new feature that lets us expand this query to express which component code we're going to need in order to render the data that matches a specific type. So essentially, we're also treating the code as data itself. And here, the same conditions continue to apply. So if the post ends up being a video, we know that we only need to download the video component code. In practice, we can't just deliver this code as part of the GraphQL request, so we still need to deliver it separately. What this does allow us to do is that as the server is resolving this query, when it knows it is going to return a video post, it can immediately let the client know it needs to download the video component code, so that hopefully we can show the final content sooner. All right, we've talked about a lot of things here. Let's recap what we've covered. This is where we started. We download the code, and then the data, and then we have our final render. First, we parallelize the code and data downloads. Then we split the code download into just the code we need for the different phases: loading, render, and after render. And finally, we stream our data so we can render meaningful content earlier, even if we can't render everything. But all of these improvements are trade-offs, and we've earned other problems along the way. Looking at this timeline, there's a lot of moving pieces here, and this doesn't even include things like CSS and images. How do we coordinate when we're ready to show a loading state? And then after that, how do we coordinate when we're ready to do another render pass? We need to handle the loading experience carefully. If we get this wrong, the content can jump around, and the text, images, and icons can come in at different times.
Yeah.
Let's look at that again. This doesn't look good. What's the right way to do this instead? We want
I like the fact that she said, like, this doesn't look good, right? Because actually it feels like it's loading first. It's kind of like an structure. Like you load first the menu, then you load the middle section. Yeah, it's definitely loading top down, left to right. Yeah.
to load the content, we load the top bar. What's the right way to do this instead?
Top?
We want to load the content in the order we read. So in English, we want to load top down and left to right. First, we load the top bar, and then the left column, and so on.
That's very, very interesting, right? Because the top part, then top, left to right. Top, left to right. Wow. It's really interesting. And I guess like if you were in like building a product for, I could say, Arabics or people from those countries, well, not from those countries, but from those places, I think they read the opposite, right? Creo que lo leen como al revés, which is right to left. But this is very nice.
In order to do this, the different pieces need to be coordinating.
Yeah.
Any of the components on this page might be waiting on data.
So I guess like basically with this kind of like 1, 2, 3, 4 sort of conditions, I would say like they are creating some sort of like a restrictions or conditions based rendering logic, where basically you specify like this top part is the number one thing that I need, then this second part is, so basically you kind of like impose an order, and the rest, like the application basically will make sure that will render everything in place. So it will basically fetch the data from the top bar, then from the left bar, this part, and then the last piece will be this this middle section. I'm very curious, to be honest with you guys, to see if actually Facebook is being loaded in that way. Let's see. I guess so. Yeah, I guess like Facebook, that could be a great exercise. Like now, all of you who are watching the live stream, or if you are watching this video later on, I want all of you to go to facebook.com, open the inspector, and hit the refresh to see how is the experience being loaded. You can actually on Google Chrome, you can throat and say, for example, you want fast 3G network. I see. But that's very interesting.
Data, code.
It's actually, I don't know, guys, but when you see these kind of conferences, and it's not like I watch them very often, so that's one of the things that I want to do this more often with you and the channel, like watch more conferences together. But once you watch this type of conferences, you realize that every single small decision that you take on a product is, in a product like Facebook, is being carefully thought to the limits, because basically like building a framework that is on top of React to manage the data, as well as letting you specify which sections of the UI should be loaded first and how do you preserve that loading experience. That's incredible. For sure, it's not a problem that we will commonly have, but it's definitely
or
incredible.
images. And historically, centralizing the experience with React would have required a lot of engineering overhead. Now, the new React Suspense component can help us. As Yuzi said, Suspense is React's system for orchestrating the loading of code, data, and images. Put more succinctly, Suspense lets components wait for something before rendering. So here we have a post. If we wrap it in a suspense boundary, then React can coordinate whether to show a loading state or the full content. And the suspense boundary works like a try-catch. First, React will try to render the content. But one or more of these might be waiting for additional resources. Let's say the body is waiting for the image. It can throw a promise to let React know it's not ready. And the suspense boundary responds to that and renders a loading state instead.
Whoa.
Then, once the content is ready, we can replace the loading state with the final content.
Whoa.
And React Suspense simplifies the code necessary to make this happen, and these boundaries are nestable. When nested this way, we can create the top-down and left-to-right loading experience we're looking for.
Whoa,
Let's
whoa,
look at
whoa,
another
whoa,
video
whoa,
of what
whoa,
these
whoa.
look like all together. And this page loads in the same amount of time as the one that we saw earlier. This gives...
Wow. I actually have never used React Suspense, but after this presentation, I want to start using it. That was amazing.
So it's a small number of paints. Images come in at the same time as the content, and the content doesn't move once it displays. And Suspense provides the veneer to bring all of this together and let us bring the code and data down in incremental pieces without sacrificing the loading experience. So I've just started to touch the surface of what performance in a client-side app looks like at scale, and we're still iterating and learning. Tomorrow morning, Joe will dig deeper on the relay changes, and Brian will talk about using developer tooling to debug and profile React components. Thank you.
Something that I really love about the end of the interview,
Surface of what performance in a
the end of the video, is that she said something like, oh, but web performance is something that we are learning through the process, or we are keep learning about it. So we are always open to blah, blah, blah. I think that like that end, like welcoming the community to actually give you more ideas, feedback, etc. is really great, because people will be like, oh, you're humble. That's great. So that's a really nice tip that we have learned out of this presentation as well.
Client-side app looks like at scale, and we're still iterating and learning. Tomorrow morning, Joe will dig deeper on the relay changes, and Brian will talk about using developer tooling to debug and profile React components. Thank you.
Thank you. Nice, 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 nice. ¿Qué os ha parecido? Did you guys like it? What are your thoughts on this? Did you enjoy it? I found it very, very interesting. We have 7 more minutes here on YouTube because we are gonna transition over Twitch. And actually the last video that I wanna watch with you today is this one about React and the music industry. It's kind of like another sort of video which is more open and it's more interesting. I have not watched it, so I don't have any references, but I think it's very cool, like to see like React and the music industry. Like, I don't know, it's very uncommon to watch a video over a conference that says React and X industry. So let's keep watching that. And as you know, guys, we have 7 more minutes before we switch over Twitch. So we will switch over Twitch to continue the live stream. And there I will be doing more stuff, such as like classifying music for stream radios. And we will keep watching some more videos. So let's watch the last video. Today you're not talking too much on the chat, guys. I'm very disappointed. What's going on? No estáis hablando mucho en el chat, chicos y chicas. Estoy decepcionado hoy. ¿Qué os pasa? Okay, let's watch this.
Let's do this. All right. So I sold millions of records, and I have over 10.
Hold on. I really love the way this guy joins the stage like, let's do this. I love the energy. I love his energy, bro. I love his energy.
So, let's do this. All right. So, I sold millions of records, and I have over 10 years, or well over 10 years of software development experience, and I'm going to tell you why they are the exact same thing.
Whoa! Actually, I wanna talk with this guy because if he's on the music industry, like we should definitely talk. What is his name? J. Johnson. I love his energy. He's so vibe. Honestly, he's incredible. I like it. But what is this guy? So J. better known by his stage name, is an American rapper, record producer, and songwriter. Born in Atlanta, Georgia. Nice. Wow. So he's very popular apparently. I didn't know this guy. You have his name here. Jamie Gill J something like that. So nice.
Of hands, who here is a musician? Artist, DJ?
I am.
Oh my gosh, that's crazy.
I am.
If you're live streaming, that's like 100% of the people, just to let you know. All right, so a little bit about me. My name is Jamelle Johnson, AKA Stat Cash on GitHub. I have a lot of sysadmin experience, also some front-end development experience, app architect, as well as a team lead, avid debugger, and even more avid rebugger. So really, really happy to be here, but also I'm known as J Dash. I'm an artist, producer, songwriter, and composer. My song, The WAP, recently went double platinum in December. Thank you. Appreciate it. I licensed a lot of music, TV and film, and and also in December recently scored my first film called 83 Days.
I want to meet this guy. He's dope. He's dope. Any of you know this guy? Like, he's amazing.
Which nominated for 15 awards and won 10. So, programming, does that equal hit records?
Whoa.
Not really. It's actually more of a one-way street from what I've seen, just because, really great musicians also tend to make great programmers. If you're a great coder, it doesn't mean you should pick up a guitar and you're just going to immediately start shredding.
I saw that.
So, not saying that you shouldn't, but just from what I've seen in the 10 minutes of free time I have to make this presentation. So we're going to look at a few ties that kind of bind the two things together. First being orchestration.
3 minutes
to work
of
on
free
specific
time.
aspects of compositions require the composer to hold the remainder of the musical structure in their imagination. It's a great quote. And it's something that developers and musicians do every day, right? I mean, you guys write components that have to be a part of a larger structure, and you have to learn how to orchestrate. The next thing, recognizing and manipulating patterns. Musicians enjoy the why and how of music. They can learn to ask the computer the same types of analytical questions we've been asking ourselves of the music for years. It's something that you guys do all the time, especially the guys that do these Rubik's Cubes here, which I'm sure there's a few. Understanding how patterns work, design patterns, as well as musical patterns is pretty much the same thing. Spatial and temporal skills. So both music and programming are very regular and mathematical in nature, yet contain a strong element of artistic creation. I guarantee if I asked a bunch of you in here if you feel like what you do is very robotic or more artistry, I can almost guarantee you have a bit of that art connection.
Yeah,
right?
definitely.
So kind of the same
Fully
thing.
agree with you, bro.
Also, you're great individuals and collaborators. So you're really good at what you do individually, but at the end of the day, if you don't work well as a team, then you can't really build great software, right? Great quote here. No one can whistle a symphony. It takes a whole orchestra to play it, by H.E. Lecoq. Last but not least is one of my favorite quotes of all time, which is, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Has nothing to do with the quote there, but I had to say that. But also a tie that bind is the gratification after a little bit of depression. Sometimes when you're debugging something, you're like, I hate coding, I'm the worst at this. Why do I do it? But then you figure it out, and it's like the greatest thing in the world. So, you and I are going to play a game. You guys ready? Yeah. Sweet. The rules are, based on the project description that I give you, you get to guess on whether it's a tech or a music project. Does that make sense?
That makes sense.
All right, here we go. Let me hear you say tech. Let me hear you say music.
Music.
All right, you're in. Here we go. First project. We had ambiguous requirements, required some agile development, continuous delivery, and tight deadlines. You can read the little descriptions there on each one to get a little bit more insight. Do you guys think it's tech or music? For tech guys, let me hear you say tech. Tech. If you think it's music, let me hear you say music. Music. You guys are cheating. That was everybody. It was actually, I made the theme song for the San Antonio Spurs this year, and it was the process that I used to actually do that. We had some tight deadlines. I had to understand the requirements from my client, and a lot of iteration, but continuous delivery, and we ended up happening. If you happen to be at a Spurs game, make sure you listen to that. Check that out. I am there with you in spirit. All right. Second, use some data insights, test-driven development, lots of third-party software, and a lot of midnight releases.
Music or software?
What do you
Both
think?
of them.
Tech?
Both.
Music?
It will be music, because this guy is a
are
producer, no?
Cheating, I think. Saw my slides. This is actually my process for releasing music on streaming platforms. We actually do a lot of testing. There's a lot of tools for artists and creators now where you can figure out where your listeners are and actually target them with advertisements or new music and things like that. So I actually go through the same process I do in tech development as I do for releasing music as well.
Wow.
Ready for the next one? Had to gather some requirements, lots of user testing, really had to understand the science behind what we were doing, and then when we thought things were one way, we had to trust the data to actually tell the real story. So
could this be like music as well, in the sense that, for example, you can understand the science, like why do users, for example, listen to certain music genres, or why do they prefer this pop type of music? Or trust data could be as well, like how many streams does your music get and stuff like that, right? So it's very interesting, because actually the way we think about music is very similar to the way we think about coding, in my opinion.
Tech? Music?
Music.
All right, you guys are catching on here, man. It's actually the process to score a feature film. I had to work with the director to really understand what emotions we need to convey with music, but at the same time had to trust when, we would test the scenes out and it would go a different way and we'd figure it out. So sounds similar to tech, you guys think? All right, last but not least, a lot of late nights, even more foul language, a lot of drunken hook writing, and some really bad decisions.
Coding.
Tech?
Tech.
100% of the people were like, me too. Yes. It's absolutely tech. This is actually my process for creating React software. Sweet. So I think there are a lot of ties that bind, tech and music creation together. I actually spend a lot of my free time, if I'm not advocating for music education or, writing music for some artist or TV and film, I try to figure out what makes these experiences the same. And at the end of the day, both fields of expertise require us to put in a lot of time and make a lot of mistakes to gain our experience. Yep. And experience is what you get paid for. So you make sure that if it takes you 30 minutes to do something that it took you 10 years to learn, you're getting paid for the 10 years and not the 30 minutes. Make sense? Cool.
Let's repeat that.
So you guys follow me. I appreciate you. I love you guys.
Stack hash, the real J-dash. Let's see the final closure.
So you make sure that if it takes you 30 minutes to do something that it took you 10 years to learn, you're getting paid for the 10 years and not the 30 minutes.
Oh, yes. Oh, yes, boy. Oh, yes, boy. He literally said, if it takes you 10 years to learn something that you are doing for 30 minutes, you will need to get paid for those 10 years and not for those 30 minutes. Probably one of the best quotes that I've heard quite in a while about software development and get paid.
Make sense?
Makes sense.
So you guys follow me? I appreciate you.
Absolutely, I will follow you, bro. I want to follow it. The real guys. All of you go and follow this guy until we saw you on Jorge's live stream and quote me. Wow, this man is honestly really great. He didn't share, honestly, I feel like this talk was more motivational than anything, because he actually didn't share anything very crazy about software development or anything new. But he was very, hey, Domini, welcome, bro. How are you doing? He didn't share anything very amazing about like software development, but I think something that resonates me a lot is that you can the same processes that you use for solving solving problems while you're a software developer, it's quite like it's very similar to the mental process that you will go through while creating music or while creating art. Like as you saw from his presentation, ¿Cómo estás, Domini? As you saw from his presentation, like all the processes that he did for like building software, like building songs, basically, like I totally see these to be part of like a software development firm. Like ambiguous requirements, like in the music industry you will have a lot of questions like what type of music do we want to make, what's our audience, when should we release these, who is going to be the singer. And you have the same when you're developing software. Like you most of the time don't know like a lot of requirements that you need to go to your PM, you need to go to other people to actually get those requirements. So totally true. The agile development, like in music, from my experience there, everything is super quick. Like, oh, I make this, I send you the test, you test it out, you send me some more feedback and some ideas. What is super slow in the music is actually the delivery, like when you need to release that to final customers. But the stuff when you're creating music is so fast and you can collaborate with others. So totally agree. And then like continuous delivery and fit deadline, that could be applied for software and music. So one of the things that I really love about this presentation from this guy is that actually I see a lot of parallelisms between coding and creativity, like to being a software developer and to be an artist. Like for sure, like at the end of the day, we're more predictable in the sense that when you want a next result, there are certain ways to solve that particular problem. But at the end of the day, for example, if you see music, like music at the end of the day is all about pattern, it's all about rhythms. So it's very similar in that sense. So that was great. So guys, it's been 1 hour and 30 minutes. So great. And as I said on my tweets, now we are gonna move over Twitch to keep continuing the live stream. So we will see more. Well, actually, probably we will not watch more videos for today. We will probably jump over classifying some music with string radiox. But we will do that. Let's see if we want to watch some videos or not. So thanks so much for tuning in, guys. It's been great. You have been here for 1 hour and 30 minutes. So I appreciate your time. I will put you right now the link to go to the Twitch channel, and probably in 5 minutes we will start the live stream. So go to Twitch. So thanks so much and see you very soon, guys. Subscribe and like the video. Ciao. The party. Oh, sorry. I was trying actually to put like the party continues over Twitch. Let me see if I can do that real quick. Thanks. Thanks. Oh my god. Thanks for watching. The party continues on Twitch. Twitch.tv/JDFerreiro. That's my Twitch account, and we will continue the party there. So let me see. Oh my god, this is too much. Let me see. Let me resize this. Okay. Thanks for watching. Oh my god, guys, sometimes this program drives me nuts. Okay. All right, there we go. Ciao, guys. Thanks so much for watching. See you very soon on Twitch. Just make sure that you will go there so you will not miss. Ciao, ciao.